So what does Kuhn says? Well, say, well, in 1959, he was invited to a conference in Utah, in the United States. Kuhn, by the way, was a physicist by training. He got a degree in physics at Harvard. He was sent to Europe as a soldier during World War II and came back to Harvard after World War II to get his PhD, which he got under the supervision of Johann van Vleck, who would later earn a Nobel Prize for Physics. And Kuhn was a physicist. As he said in his last interview, Kuhn died in 1996. In his last interview, he described himself as a physicist turned historian for philosophical purposes. So indeed, he was a physicist who started working on the history of science. And then based on his studies in the history of science, he developed a philosophical theory about the nature of science, the progress and the development of science itself. Okay, so he was invited in 1959 to a conference in Utah. And the subject of the conference, the theme of the conference, was so-called divergent thinking, meaning being open-minded, the importance of being open-minded in everyday scientific work. That's exactly in line, so to say. There was no reference in the Utah conference to Popper, but Popper had exactly this attitude. We have always to be open-minded, test our theories in the best way we can, and replace ideas that get refuted with new ideas, new theories, and go on. We should never be attached to our theories to a level that we are not willing to let them go. That's Popper's idea. We always have to have a critical attitude towards our best ideas, even if we care about them because we came up with them after a great effort, maybe. But we should always be ready to let them go in front of contrasting or contradictory evidence. Well, that was the idea. Always be open-minded. Always apply this kind of divergent thinking. Well, Kuhn, in his contribution to the conference, talked about exactly the title of which contribution was The Essential Tension, the paper that was later included in the collection, The Essential Tension, published in 1977 by Chicago University Press. Well, Kuhn in that contribution talked about the relevance of convergent thinking as opposed to divergent thinking. So let me read just a few lines from this paper, 1959, The Essential Tension. I do not at all doubt, Kuhn says, that this description of divergent thinking and the concomitant search for those able to do it are entirely proper. Some divergence characterizes all scientific work, and gigantic divergences lie at the core of the most significant episodes in scientific development. But both my own experience in scientific research, as I said, he was a physicist, he was trained as a physicist, and my reading of the history of the sciences, and then he devoted himself to history of science because of that course that led to the book, The Copernican Revolution in 1957. So both my work as a practicing scientist, as a practicing physicist, so to say, and my readings and my research in the history of the sciences lead me to wonder whether flexibility and open-mindedness have not been too exclusively emphasized as the characteristics requisite for basic research. I shall therefore suggest below this essay that something like convergent thinking is just as essential to scientific advance as is divergent thinking. And then he says, I am elsewhere studying these points more historically, with emphasis on the importance to scientific development of revolutions. Elsewhere is a reference, of course, to the structure of scientific revolutions, which was in 1959 he had already started, but would be eventually completed in 1961. He says, flexibility, again, flexibility is not enough. And what remains, what complements, so to say, flexibility is not obviously compatible with it. Drawing from various fragments of a project still in progress, again, the structure of scientific revolutions, I must now emphasize that revolutions are but one of the two complementary aspects of scientific advance. So the critical attitude, the replacement of old ideas, refuted ideas with new ideas, replacement of theories, these dynamics of theory change that, according to Popper and others before him, characterizes the scientific enterprise, is only but a part of it. Revolutions are but one of two complementary aspects of scientific advance. And indeed, the structure of scientific revolution, which is the book here, is not totally about revolutions. Indeed, revolutions are begin to be discussed in chapter 9. So there are 8 chapters out of 13 chapters of the book devoted to what comes before a revolution and what makes a revolution possible. So it is only in chapter 9, the nature and necessity of scientific revolutions, and then chapter 10, revolutions as changes of worldview, that Kuhn deals with the idea of revolution. So this is just, revolutions are just one of the two complementary aspects of scientific advance. Almost none of the research undertaken, Kuhn says, by even the greatest scientists is designed to be revolutionary, and very little of it has had any such effect. On the contrary, normal research, and this is another of Kuhn's terms, normal research, normal science has a very specific meaning in the context of Kuhn's philosophical production. We shall come to that. On the contrary, normal research, even the best of it, is a highly convergent activity. So not divergent, but convergent, based firmly upon a settled consensus acquired from scientific education and reinforced by subsequent life in the profession. So scientists are trained at university on specific textbooks that introduce them to the kind of scientific activity they will be dealing with in their future career. And then, so both these textbooks and their practice, their life, everyday life in the laboratory, in the observatories, or whatever, their subsequent life as practicing scientists is not does not make them critical towards their theory. They make them, they encourage them, Kuhn says, to achieve a settled consensus, which has been acquired by those that came before them, and which they will try to reinforce. Typically, and this is the end of my quote from The Essential Tension, to be sure, this convergent or consensus-bound research ultimately results in revolution. So revolutions are indeed key moments in science and in the history of science, but they are only moments. Moments being not instants, moments at times take centuries, but they are temporary periods in the history of science. The first scientific revolution, so-called the astronomical or Copernican revolution, took, for example, broadly speaking, between 1543, the publication of Copernicus De Revolutionibus, and 1687, namely the publication of the first edition of Newton's Principia. So it's not an instant, of course, but they only cover a limited time span. For most of the time, scientists are not really challenging their points of view. They are, in fact, supporting them or trying their best to support them. That is why Kuhn says there are much longer times of normal science. Normal science simply meaning this is the average, the standard kind of activity that it's being carried out during most of the time in the history of a scientific discipline. So it is not only revolutions, but it is mostly normal science. That is why, and Kuhn says so explicit, well, not really explicitly, but quite explicitly, at page 77 of his book, of the Structure of Scientific Revolutions, he says, no process yet disclosed by the historical study of scientific development at all resembles the methodological stereotype of falsification by direct comparison with nature. So what Poppers had been preaching, so to say, or theorizing about, namely that we have to distinguish science from pseudoscience, oh, no, well, not pseudoscience, science from metaphysics, even though not regarding metaphysics as meaningless, as I said in the past class. But anyway, this open-minded attitude, focusing on the refutation of theories, well, this kind of attitude, Kuhn says, is a fiction. There is no such thing as falsification. No process yet described, repeat it again, no process yet disclosed by the historical study of scientific development. So if we look at the history of science, we will never find such a thing. It all resembles the methodological stereotype of falsification by direct comparison with nature. By contrast, we have to look at the actual practice of science in current laboratories or in current observatories or whatever, in current universities, and then we have to look at what was the past practice of science by studying the history of science and come up with something different. If we do so, and this is actually the very first chapter, actually the very introduction to the structure of the scientific revolutions, we shall get, if we look at history and the actual practice of science, we shall get a picture that is very different from these fictional models offered by Wittgenstein, by logical positivists, or by Popper himself. And indeed, the first few lines of the book, from the introduction titled A Role for History, are the following. History, and I quote, if viewed as a repository for more than anecdote or chronology, could produce a decisive transformation in the image of science by which we are now possessed. So history must become the focus of our philosophical reflection. We cannot simply come up with a model that sounds plausible, that sounds reasonable, that sounds challenging, as Popper did, but we have to look at the actual practice and the history of science, and we shall see something very different. But the way we have to approach the historical records is not simply that of choosing anecdotes or specific moments from time to time that particularly that fit particularly well our own ideas about the nature of science and the nature of the progress in the sciences. So, for example, if I am a falsificationist, if I follow Popper's prescription, so to say, or I'm a follower of Popper's ideas about the nature of science, I'm not supposed to go to history and pick up only those elements that fit my model, in which theories were advanced and tested and refuted and then replaced by other theories. I need to look also at other moments in the history of science in which these things did not happen. As Paul Feyerabend later said, the history of science is not to be regarded as a sort of supermarket in which I go, pick up whatever I need to support my own point of view that fits my specific or particular model, and disregard everything else simply because I'm not interested. So if history viewed as a repository for more than anecdote or chronology, could produce a decisive transformation in our very way of understanding the nature of science.